Okay, great. Well, I'm going to get started because we have a whole prep quiz to go through, and it might take the whole time period. So I'm going to honor your showing up on time and get started. So what's going to happen, I'm going to go through a copy of the prep quiz, and hold on a second. It's not at the top. There we go. I also have what are called detailed solutions. Some of the questions I can't really show all the work over here, so I will click on the detailed solutions, and I'll also post those after we finish the chat. Justine, can you hear? I think she probably can. Oh, let me go down. Okay, good. All right, Ashley, can you hear? Okay, good. All right. Okay, so what I was mentioning before, we're going to go through a copy of the midterm prep quiz, which I hope that if you haven't already, you will take advantage of that. And periodically there are questions on the quiz that require a little bit of work, and so I've got what I call detailed solutions, and I'll post these afterwards. It's just easier than me trying to write the stuff up here. I put those together before we did the chat. So let's go ahead and get started. There are 3 of you here, so if you want to answer the questions along the way, that's great. So question number 1, there's some definition questions on here. So the first question says, the Ionic Greek numeration system is an example of which type of system? Multiplicative, additive, or ciphered? Anybody know that one? What kind of a system is that one? Remember, we learned about all these different systems in Unit 1. Anybody want to try that? Is it multiplicative, ciphered, or additive? A couple people are typing. Let's see what Justine. Ashley said it's additive. Justine, what do you say? I see a multiplicative. Multiplicative. Actually, it's a ciphered system. So take a look again at your notes. That one's actually ciphered. All right. Yep. Okay. All right. Using the table, write the Egyptian numeral as a Hindu Arabic numeral. Okay, that's fine. That's fine. That's fine. If you don't want to give the answers, I'll do them. That's fine. So this one, remember, you're always going to have the little chart. You're not going to have to remember that. And all I want you to do is translate it from the Egyptian numerals back to our system. So we see a scroll, which is 100. Yeah, this is easy. This is an additive system, right? Because all you do is add up the symbols. So that's a C is 111. And then I have Roman numerals. And again, you'll have the system, the numerals you'll be given. So they want you to write this numeral in our system. So remember how we work on this one. If we have a symbol, let's see, so we've got an M here, which is 1,000. Then we've got a C, which is 100, in front or to the left of the M. So what does that tell us to do? It actually tells us to subtract, doesn't it? So I've got 1,900. L is a 50. And then I've got a 10, 60, so 63. Somebody got it who had a constants. So it's going to be answer D. All right, then we have Chinese. Now remember how Chinese go. They grow in groups of 2. They're written vertically. And remember, the symbol is going to be over a number that gets multiplied. So if we take a look, this is a 3. So what do I have? I've got 3 times. And then I have to figure out what this symbol is here. And if I look across, that's a symbol for 100. All right, and then I go down to the next 2. And I've got, what's that top one there? It looks like a 6, I think. Yeah. 6 times, and again, it's over top of a 10, so I'm up to 360. And then the last symbol is a 7. Somebody had it. 367. A couple people have it. This one's 367. All right, and then here's the Ionic Greek. And they want us to pick the right representation for the number 8,072. Now, remember what we did on this one. Let me make it a little bigger. Oops. Remember what we did. In order to multiply by 100, remember we used the iota up here, up and to the left of the symbol. So that's going to be 8. Where's the 8 symbol? Is the eta. So I know I can eliminate these two. okay, because they're not going to be big enough. So I'm going to focus on the last two. And these have both got 8,000, and then I want 72. So let's take a look. Here's 70, and there's 2. So it's going to be, let me look again. 70 was the Omicron, and 2 is the Beta. So it's going to be answer D. All right, and again, you'll have the table, so you don't have to memorize the symbols. That'll be given to you. All right, let's talk about the next section we talked about were the positional or the place value systems. I just gave you the answer. Another name for the place value is also called a positional. And then this is where we learn to write the expanded form. So we want to write this number in expanded form. So how do we do that? This is going to be 9 times 10 to the, anybody want to do that one for me? Plus 7 times 10 to the, remember the positional values in our system. They're 1, 10, oops, 10 to the 1, and then, oh, I'm not doing very good with my freehand pen tonight. Let me type it. What comes next is 10 squared, and then if you keep going to the left, the next positional value is 10 to the third. Oops, sorry, superscript's not working there, 10 to the third. And so the answer, yeah, the answer has to be D right here. Okay, because the 9, remember here is 9,000. So 9 times 10 to the third plus 7 times 10 squared plus 1 times 10 to the 1 plus 2 times, this position here is 10 to the 0, which is 1, or just simply 10 times, or 2 times 1 rather. All right, Babylonians. Now in this system, you're going to have to remember some of the rules, because now we're getting into some rules in these systems here, aren't we? So Babylonian, there's only 2 symbols, for a 1 and a 10, and remember this symbol here was for, anybody remember what this meant here? This was one of the systems where it actually introduced the concept of subtraction. So anybody want to try this one? So we start, remember we have one grouping over here and one of the positional values. And remember what you've got here. You've got, anybody remember the positions? They're 1, 60, 60 squared, 60 cubed. Right? So we've got 2 groupings here. We've got 60, and then I've got 10 minus 2 is what? 8. So 60 plus 8 is 68. All right, and this one you have to be careful, and this is probably not pulled apart enough. There should be a space here to let you know that this is going to be, but it has to be subtraction from the 10, otherwise it wouldn't make sense. So this is part of the single digits. But again, you've got to remember your positional values, and in this case it's 60, 160, 60 squared, 60 cubed. All right, and then we had the Mayans. Remember how the Mayans worked. I might have a detailed, yeah, I have a detailed solution on this one. Let me go here and make this bigger. All right, because you have to remember on the Mayan what the positional values are. Remember the positional values there were 1, 20, 18 times 20, 18 times 20 squared, 18 times 20 cubed. All right, so what do I see here? Okay, I read from top to bottom, and I see a symbol for 20. I'm sorry, hold on a second. I've got 1 up here in the 20 position. So I've got 1 times 20 up here, and then this symbol is a 7. So I've got 20 plus 7, or 27. Let me jump back over. So this one is 27. Okay, so you're going to have to remember your positional values for the Babylonian and also for the Mayan. Okay, this time we're going to go the other way. They gave me the number and they want me to pick the right set of symbols. So let me click over here for this one. All right, so 3750. So what do I do here? Remember the positional values are 1, 20, 360, 720. I pick the largest number, largest positional value that's less than the number. So I'm going to divide it by 360. So 750 divided by 360 gives me 10 remainder 150. I go to the next positional value, which is the 20s. I'm going to take 150 and divide by 20. And I get 7 with a remainder of 10. So here's the symbols I need. I need a 10, a 7, and a 10. And so let's take a look up here. What's the symbol for 7? 2 dots over a bar. Is that right? Wait, 10. I'm going 10, 7, 10. I'm sorry, 10 first. So 10 is a double bar. And then 7 is 2 dots over a bar. So let's take a look. So it looks like it's A, right? 10, 7, 10. And if I think about the values I worked out down here, that would be the correct answer. The correct answer for this one is A. There we go. Okay. Now we're getting into the last section on the numeration systems, which is different bases. So this is a definitional question here. In the numeral 731 subscript 6, the 3 represents 3 times what? Think about your positional values in base 6. So what does the 3 represent here? 3 times what? This is the 1s, and this is the 6s, and this is the, or 6 to the 1, this is the 6 squared, so 3 times, anybody want to try that one? That's 3 times, no, okay, 3 times 6. Alright, I think somebody got it. Let me scroll down. Yeah, Constance had it. Okay. Now we want to do a conversion. We want to convert from base 7 back to base 10. Alright, so I've got a detailed solution for you on this one. Alright, write it in expanded form. Remember the expanded form. So my positional values are 1 and 7, so I've got 1 times 7 plus 4 times 1. 7 plus 4 is 11. So this is 11 in our base 10 Hindu Arabic system. So going that way is pretty easy. Write it in expanded form and then just add the numbers together to get it back into base 10. Now we want to go the other way. We want to go from base 10 to base 8. I think I have a detailed solution on this one. Yeah. So you want to think about the positional values in base 8. 1, 8, 8 squared, which is 64. And I've got a 68, so I want to use the positional value that's less than the number I'm converting. I'm going to take 68, divide by 64, and I get 1 remainder 4. So I go to the next position. I can't divide 4 by 8, so I'm going to put a 0 in that position, and then my 4 remainder goes in the last position. So 68 converting to base 8 gives me 104 base 8. Everybody remember how to do those? All right, moving on. So that wasn't too much in that section. Now we're into 5.8, definitional question. In medieval times, people referred to the golden proportion as the, anybody want to try that one? Yeah, the divine proportion. I gave you the same answer here. That doesn't make sense. Determine whether the sequence is a Fibonacci, and if it is, determine the next 2 terms. So let's go over just real quick, review what I don't have it over here. I thought I did. No, I didn't. Okay. So we can just go through this. Remember the Fibonacci. The terms are the sum of the prior 2. So 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. It looks like a Fibonacci type. So what would be the next 2 in the sequence? Anybody want to try? Yeah, 21 and 34. Yeah. That's pretty easy. Determine if the item is designed in accordance with the golden ratio. So let me flip over here. This was the one I had it for. So what you want to do is just set up the ratio. So take the 67.96 and divide by 42. Remember the golden ratio is about 1.618. So the answer on this one is yes. Not too difficult. I can't really ask you that much on this section. There's not that many types of questions we can do. And then this is the modular arithmetic definition question. The elements in a modulo M system consist of the numbers 0 through what? Anybody want to try that one? M minus 1, yes. Very good. All right. If May is your starting month, what month will it be in 73 months from May? So let's go over here. So what do? I take 73. Now we're on months, so the modulus system is 12. 73 divided by 12. I get 6, remainder 1. So what month is it going to be in 73 months from May? Which one's it going to be? You're going to go ahead by 1 month, which is June. Yeah. Oops, wrong one. Let's flip back over. Yeah, this is June. Okay, that's another detailed solution one. So this one is, if Wednesday's your starting day, what day will it be in 156 days? Now remember, this time we're on a 7-day system. So we're going to take 156 and divide by 7. And I got 22 remainder 2, so I move ahead 2 days. Wednesday, 2 days, Thursday, Friday. I don't think you'll have trouble with these. These are pretty straightforward. All right, this one. We want to know what modulus system 69 belongs to if we're in the modulus 16 system. And all that means is find the remainder. So take 69 and divide by 16. I get 4 remainder 5. So this is equivalent to 5 modulus 16. So the answer is going to be 5. Okay, 5. All right. Another modulus question. Find all the replacements less than the modulus for the question mark that would make the statement true. Okay, now this one's pretty easy because if I do the subtraction on the left side, I get a number that's positive and also less than the modulus. So the answer here is simply 5. This one's not too difficult. 5, that one's 5. Anybody has questions, stop me along the way. So, all right, now we're into Unit 2, Consumer Math. The banker's rule considers a year to have how many days? Anybody remember that one? 360, yes. Simple interest problem. I've got a detailed solution for this one. Remember simple interest, this is the only formula you need to memorize. Simple interest is I equals PRT. All right, so in this problem, my principal is 830, interest rate 9 or 0.09. Time, in this case, I'm going to convert it to years, it's 1.5. And then I'm just going to multiply 8,300 times 0.09 times 1.5, and I get 112.05, which is answer D. Any questions on the simple interest? These are pretty simple, I mean, and that's the only formula you need to know. Other than you have to know the rules for the, oh, my mind just went blank. The ones in 4.2, the Babylonian and the, what's the other one in there? The Mayan. Okay, another one, simple interest. Principal $94,400, interest rate 0.04, 2 years, same thing, you're just going to plug it into the formula and you get 75.52. Let's jump back over here, which is B. Okay, we just lost Eve, maybe she'll be back. Another simple interest problem. Okay, now this one's a little different because it's got months in it. So I wanted to show you one example where you go less than a year or you go in terms of something other than a year. So what I did here was I said, okay, the time is going to be 8 out of 12, 8 months out of 12. We want to convert it to years, which is 2/3 of a year. And then I just put it in. Oh, this one's solving, I'm sorry, I missed it. This is solving for the interest rate. They gave you the principal, they gave you the interest, they gave you the time, they want to know the interest rate. So I put in the interest, the principal, R is what I'm solving for, 2/3. So I simplified the right side first. I took 6,338 multiplied by 2 and divided by 3. And then I'm going to divide both sides by that quantity. And so I get an interest rate of 3.5%. So that was a little bit tougher. We were solving for the rate instead of finding just simple interest. Let's see. Okay, another one. I think I probably have a detailed one for this too. Yeah, Chris opened a new maid service company. She borrowed $56,000 from the bank at 0.05% for 1 year. Find the interest. Same formula, $2,800. Simple interest is pretty easy. All right, now we're moving into the compound interest. So if you notice, the problems are in the order that we studied in the course. So interest that's computed on the principal and any accumulated interest is called what? Probably just gave you the answer for that one. What do we call that? We call that, anybody, that's the compound interest. All right, so you're going to have the formulas. Here's the formula for the compound interest. Use the compound interest formula to compute the amount accumulated $1,000 5 years, 3%, compounded quarterly. And remember, in this formula, n is equal to the number of compounding periods per year. So for quarterly, n is going to be 4. So let's jump over. Oops. Sorry. Not on the right one. Here we go. Okay, so here's my formula. My interest rate was 3%. I put that here over the 4, and then 4 times 5. Principal's up front here. What do I do first? I start here. 0.03 divided by 4, add 1. I got 1.0075. Raise it to the 20th power, and then multiply by 1,000. And then I got 116118. 116118. All right, any questions on that formula? 116118. Okay, now this is the present value. Okay, so let's just go back for a minute. This is the compound interest formula. So in other words, if I put aside this amount of money at this interest rate, compound it this many periods a year for this many years, this is how much I'll accumulate. The next formula is the one that tells us how much do I need to put aside each time period in order to accumulate a certain amount of money. So we want to accumulate $46,000 after 7 years at 3% interest, compounded semi-annual. So we want to know how much do we need to invest now. All right, so here's my information. 46,000 goes in my numerator. 1 plus interest rate 0.03 divided by semi-annual means twice a year. So again, in my formula, I'm going to do this part first. 0.03 divided by 2 gives me 0.015. Add it to 1. I'm going to raise it to my exponent of 14. Get this quantity here, and then finally I'm going to divide that number into 46,000. And so I have to invest $37,345.07 now in order to accrue $46,000. How much? What was it again? Sorry, I don't do the wrong answer. 345.07. C. All right, just a comment. Notice the difference between this one and the annuity formulas that we used in the last section. In this formula, you put in the whole amount now in order to accrue. In the annuities, you're putting in a certain amount each time period. So that's the difference between the two approaches. Okay, effective annual yield. 1 year at 1.5% compounded monthly. This is that annual APY formula. We want to know what the effective simple interest rate would be with the compounding accounted for. So here's the formula. 1 times 1 plus the interest rate divided by the number of compounding periods a year, raised to 1 times n. So in this case, 0.05 divided by 12, add 1, raise it to the 12th power, subtract 1, and I get 0.0151, which is 1.51%. Notice this answer is always going to be slightly larger than the stated interest rate, because you're coming up with the effective yield as if it were simple interest. So one hint when you're working the problems, it's always going to come out to be slightly larger than the stated interest rate. All right, so that's 1.51. So actually for this question, here's a tip on taking the exam, none of the other answers meet that criteria. So there's a tip for you. It has to be greater than the number you started with. Okay, the total amount of money the borrower must pay for borrowing the money is called what? Who remembers that one? What's the total amount of money that the borrower must pay for borrowing the money? Anybody remember that one? Yeah, that's the finance charge. Good. Yep. Okay, monthly payment. Now again, you'll have the formula. So they want to know if you're financing $1,070 at 8% interest, 12 payments a year for 4 years, what's your monthly payment going to be? All right, so for our problem, 1,070, interest rate 0.08, monthly payment, so n is 12, no, 4 years. So I'm going to drop those into my formula. The most important thing on this formula, I mentioned this in the weekly chat is the negative in that exponent. So I probably would simplify the numerator first. It usually comes out to be a number that's not too awful to write down. And then I went to the denominator, 0.08 divided by 12, plus 1. And then I'm going to raise it to the negative 48th power. My tip to you here is this number has to be less than 1. Then I'm going to subtract it from 1. And then finally I'm going to divide the numerator by the denominator. So I got 2612. 18, I'm going to round it off to 2612. So the answer here is $26.12 would be the payments. 2612. Oops. Let's try that again. All right. Okay, this is one using the table. And they want you to find the finance charge. They're buying a ski boat for $18,500. They required a 10% down payment and financed it for 36 months with an APR of 6%. Determine the finance charge. Now you could use the formula, but if you've got the table, it's a lot easier. So what do I need to know here? So we're doing 36 months for 6%. 36 months at 6%. There's my multiplier, 9.52 per thousand borrowed. So how much did they actually borrow? They put 10% down, so they didn't borrow the whole amount. So they borrowed $18,500 minus 10%. They actually borrowed $16,650. Now remember, this table is per 100 of amount financed. So take the amount financed, divide by 100, and I'm going to take 166.5 and multiply by that number in the table. And so I get an interest charge of $1585.08. That's the finance charge, which is answer A. Jump back over and do that one. Answer A. All right, another definition question. The amount of cash the buyer must pay to the seller before the lending institution will grant the buyer a mortgage is known as the... Anyone try that one? What's that called? No, not the points. This is your pay. The points go to the bank. What does the buyer have to pay to the seller? The down payment, yeah. Justine, the points go to the bank. Yeah, but you actually, if you remember on one of the slides we talked about it, when they go to settlement, the points go to the bank, the down payment goes to the seller of the house as part of the purchase price. All right, determine the monthly principal and interest for the mortgage. This is the same formula that you used in the prior section for the monthly payments, no different. So let's jump over here. And let's see, we're borrowing $71,000, 9% interest, 12 payments a year for 25 years. Same formula. Again, I would simplify the numerator. It's usually pretty easy to do. In the denominator, start with the fraction, 0.09 divided by 12, plus 1, and then raise it. Again, remember, negative exponent, so it's the negative 300th power. The number you get is going to be less than 1, then subtract it from 1, and finally divide. So the monthly payment on that loan is going to, mortgage is going to be $595.83. $595.83, which is answer D. And again, a tip to you, a couple of these answers don't make any sense. So if you think about it, you wouldn't be paying this much a month for 25 years to borrow this. This one's awful small. This one's kind of big, but I mean, usually there's one or two you can eliminate. Okay, we're going to use, what's the monthly payment on a 15-year loan of $65,700 if the interest rate is 12%? And we're going to use a table on this one, so we don't have to do the formula. So let's take a look. So what do we need to know in here? We need to know 12% for 15 years. There's my multiplier, and that's per thousand of loan. So you take the amount of the loan and divide by 1,000. Get 65.7, and then multiply that by the number in the table, and your mortgage payment is $788.51, which is answer D. Okay, so answer D. Notice this is different than the finance charge table. Let me just make a comment here. This is per thousand of mortgage. If you remember, the finance table was per 100 of a loan. So just remember that on this one you're going to divide by 1,000 in order to do the calculation using the number in the table. Okay, Justin is buying a condo that sells for $140,000. The bank is requiring a down payment of 15%. To obtain a 20-year mortgage at 7.5%, he must pay 1 point. What is the amount of the point that he has to pay? Now, just be careful on this one. Let me jump over for a second because you actually do have to do a little calculation, because remember, the points are not on the purchase price, but on the amount that he's actually borrowing. So his cost of his house is $140,000, but he made a down payment of 15%. So his mortgage is actually $119,000, and so 1 point is going to be $1,190. So make sure to read the problem, and if there's a down payment, subtract it first before you calculate the point. All right, last section. Variable annuity is an annuity that is invested in stocks, bonds, mutual funds, or other investments that do not provide what? Anybody remember that one? They don't provide what? The variable annuity. Key word here is variable. Yeah, they don't give a guaranteed interest rate. Fixed annuity would have a guaranteed interest rate. Variable does not. All right, 2 formulas in this section. The ordinary annuity formula. This is how much we accrue if we put away a certain amount of money at regular periods. And we want to invest $1,000 for 13 years, 7% compounded annually. All right, so P is 1,000. My interest rate 0.07. This is compounded annually, so N is just a 1 here, and then it's for, this should be 13 years. It's correct in the formula, I typed it wrong here, it's 13. The formula's correct though. So 0.07 divided by 1, add 1, that's 1.07. It's going to be raised to the 13th power, minus 1. And let me go back just for a second. The denominator in this case is just 0.07. It's 0.07 over 1, so that one's pretty easy. So I took 1.07 to the 13th power, subtracted 1, multiplied by 1,000, and then divided by 0.07. So $20,140.64 is how much I would accrue if I put aside $1,000 every year for 13 years. Notice the beauty of the compounding. You put aside $13,000, you're actually walking away with more than $20,000. So that's the beauty of the compounding that's happening with this. So it was answer A. All right, and then the last formula we did here was the sinking fund formula. And this is telling us what the payments are. Remember, this is what I was saying is a little different from what we looked at before. This time you're not going to put a lump sum in. You're going to put in a certain amount of money each period over the course of the sinking fund. So we want to make annual payments with 4% compounded annually for 23 years, and we want to accumulate $7,000. That's our goal. So not a big goal for 23 years, so it's not going to be a very big answer. So put in the formula the amount we want to accrue times the interest rate over the compounding periods per year. Same denominator, same fraction here in the denominator. Raised to the number of periods per year times the number of years, and then we always subtract 1. So simplify the numerator. In the denominator, 0.04 plus 1. Raise it to the 23rd power. Subtract 1 and divide. So we need to make a payment of a little bit more than $191 per year over 23 years in order to accrue $7,000. So it's $191.16. Okay. All right, so that is the prep quiz. And again, after the chat finishes, I will post these detailed solutions in the weekly chat folder, so you'll have those. Okay, Justine has questions. Go ahead. So when we have to figure out how many days from one day to another, yes, yes, that's correct. Okay. And Justine, if you were going to do that problem, I would give you that table of days that we used also. I'm giving you the different tables and all that you're going to need. You're not going to have to remember things like that. Justine, where are you seeing these? Is this on the prep? I don't think these are on the prep quiz, are they? I don't remember that I put them on there. Okay, Catherine, that's fine. Yeah, you can use the TI-83 plus. That's fine. Let me see. Constance, what if we need to find August to March? I'm not sure I'm understanding your question here. The days from August to the end of the year, and then the days from January to March. Okay, well you would find the days to the end of the year, and then find the days in the next year and add them together. Yes, Brittany, if you have a question like that, the calendar will be provided. And since I'm seeing that there weren't any examples in the prep quiz, it's leading me to believe that's probably not on the actual midterm. Because normally everything you see on here, you're going to see everything that you're going to see on the actual exam. I'll take a look afterwards and just double check, but I don't think I gave you any of those questions on the midterm. Justine, do you see Constance's question? I think that's what you were talking about. Yes, okay. Yes, the practice quiz, the prep quiz closes tomorrow night, and I'm going to explain my reason for that. There have been instances where students went in to take the proctored exam, took the prep quiz thinking that was the actual exam. So to eliminate any confusion, the preparation quiz will close tomorrow night. No, I don't have one in my math lab. If you're taking it in the fall, we're going to have it in my math lab, but it's not right now. It's still in my courses. Remember, you can go back and rework any homework just to practice. You don't have to improve your score if it's already 100%. So if you want to practice on certain sections, you're still able to do that in my math lab by just checking the option practice. So if you already have 100%, there's an option for you. Just go in and pick a homework you're having trouble with and pick practice. So that will still be available for you. And what's nice about that is you have the learning aids too. So if you get stuck. Okay. Sad face, is that what it says? Well, I'm giving you some options here. So, and I'm trying to protect you because I just want to tell you, I can't imagine, but students have gone into proctor testing and thought they should take the prep quiz, and then when I write to them later and say you didn't take the midterm, they're like shocked. Well, I know, but tomorrow, it closes at tomorrow night, so. Oh, Constance, I would just get there a couple minutes early, just so you can get checked in and not have to rush. And chances are, if it's not, actually, I think they open at 11 on Sunday, so you'll probably be in the first time slot. Justine, you have to make a reservation, so you got to pick your campus. Okay, so what campus did you pick? Gibbs? Okay, you're going to go to the TE building. You know where the Learning Support Center was? I'm sure you went there. Okay, you just go over there and there'll be signs and you check in upstairs and then they'll take you to a room with computers to take it. Okay? I have full confidence you're all going to do well. You're all doing great. The class is doing great, so. Yes, and don't forget your calculator. I don't think they have calculators to loan anymore at the testing site, so please. And the other thing is it's good for you to take your own calculator so you know how it works. I understand there's anxiety. Take a deep breath. You'll be fine. Okay, yeah, and I mentioned this too in the midterm module. You can't use a cell phone calculator at the proctored exams. It's not allowed. That's why I urge you to go and buy a calculator. You need a calculator for other things in your life. You don't have to buy an expensive one. The TI-30 series is like $10 at Walmart. So I think everybody should have a calculator. You always need it for something. But you don't have to buy an expensive one. But if you take your own calculator, you know how it works, and you don't have to sit there and guess. And the proctors can't help with that. So. Constance, does it have a memory option? Because you could put the number into memory and then just do 1 divided by and then recall what you put in memory. That would work too. There's a couple different TI-30s. But again, see, you know that about your calculator. So the other thing to keep in mind is the midterm is also multiple choice. So therefore, and most of the answers are not close together. So if you're on the right track, even if you're rounding off a little bit, you're going to see the right answer there, or close to it. Oh, you're welcome. I think Justine's still typing something. So the other people in the chat room, Lorena, Brittany, Christine, do you guys have any? Yes, they do. They reset your calculator. You're actually right. For you guys, I don't think it matters, but I don't think you'd be storing anything that would be very helpful. But yeah, they do clear the calculator. Question about the modulus that subtracts numbers. If it's less than the modulus, then that's the number. If it's more, we divide. Yes, you're correct. So if it was modulus 6 and the answer you got was 5, that would be the answer. If the number was 12 and you were doing modulus 6, you'd have to divide by the modulus. Yep. Yeah, the only thing you need to know the simple interest formula. I think that's pretty easy. I equals PRT. And the only other thing that's complicated is in section 4.2, and you need to know the positional values for the Mayan and the Babylonian. Okay, and then how the formatting on how those numbers are created. That's probably the only thing that's difficult, that you have to remember. But you'll have the symbol charts for all the other numeration systems. And the formulas, just like you see here, these are going to be available for you. So you don't have to memorize. You just have to know how to put the numbers in. But you don't have to memorize this formula or even think which formula to use. It'll be in the place for you. All right, Lorena, any questions? I know Catherine had one question. We answered that before. Okay, good. And don't forget, as you're studying, if you need help with something, just send me an email and I'll send you an explanation. Oh, good. Okay. Yeah, they send out the information this week, so yeah, you should be fine to go. When are you going, Catherine, for your test? I think you told me, but I forget. Saturday. Okay. Oh, could you make an appointment or not? Justine, no, I want to look at them first before I give you the grades. Sorry, I like to look at them. It's better for you if I do that. Oh, okay. I got you. Well, it's down overnight though, so you should be okay. But the system, hold on a second, the system that's down we were talking about was Pearson, not the learning management system where the test is, so you should be fine. Yeah, they have to do maintenance periodically, and they try to do them overnight when most students are not working in my math lab. Okay, so the grades will be released probably Monday. I usually put them out Monday morning. Yeah, I know, it's not our choice. So, but I like to look at them, and then also I want to add in your bonus points too. Remember that. So if you do well in the midterm prep, you can get up to 5 points added onto your midterm grade. And I need to put those in manually, so I'll do that on Monday morning. All right, well, I have full confidence, so good luck, everybody. If you need help, don't forget you can email me with any kind of questions that you are struggling with. Christine is typing, so I'm waiting to see what she's typing, and then also Constance. Okay, okay. Christine, I'm not seeing your message, so I'm not sure. Oh, okay. No, I have full confidence in you all. All right, good luck, everybody, okay? And then next week we start a new unit, and we'll have a chat again on Wednesday night. No homework due on Monday, all right, because we're doing the midterm this week, so you have a week off. But we'll chat again next Wednesday, and we'll be into Unit 3. All right, so have a great week, and good luck on the midterm.